algebraic methods for solving pair of linear equations. In our previous session, we have learnt about graphical method for finding the solution of pair of linear equations in two variables. The graphical method is not suitable for non-integer solutions as it may not give the accurate solution as required. There are many other algebraic methods for solving a pair of linear equations. The following are some of the algebraic methods used for solving a pair of linear equations. A. Substitution method. This method is useful for solving a pair of linear equations in two variables where one variable can be easily written in terms of other variable. To understand this method, let us consider the following example. 3x minus 5y is equal to minus 1. Consider this as equation 1. X minus y is equal to minus 1. By rearranging the above equation, we get y is equal to x plus 1. Consider this as equation 2. Substitute the y value from equation 2 in equation 1. 3x minus 5 into x plus 1 is equal to minus 1, which implies 3x minus 5x minus 5 is equal to minus 1, which implies minus 2x minus 5 is equal to minus 1. Transposing minus 5 to the other side, minus 2x is equal to 5 minus 1, which implies minus 2x is equal to 4, which implies x is equal to 4 by minus 2, which implies x is equal to minus 2. Substitute x value in equation 2. Y is equal to x plus 1, that is equal to minus 2 plus 1, that is equal to minus 1. Therefore, x is equal to minus 2, y is equal to minus 1. Thus, we can conclude the following steps to solve the linear equations using substitution method. Step 1. Determine the value of one variable, say y, in terms of other variable, say x, from one of the given equation. Step 2. Substitute the value of y in other equation and reduce it to an equation in one variable x. Step 3. Determine the value of x by solving the above equation. Step 4. Substitute this value of x in one of the given equations to obtain the value of y. B. Elimination method. This is the another method for solving a pair of linear equations in two variables where one of the two variables is eliminated or removed by equating its coefficients. This results in a single equation which can be solved to get the value of other variable. Let us understand this method with help of another example. Consider 8x plus 5y is equal to 9. Consider this as equation 1. 3x plus 2y is equal to 4. Consider this as equation 2. In order to solve the above equations, we are making any one term equal in both the equations. So, multiply equation 1 with 3 and equation 2 with 8, then equation 1 into 3 is equal to 24x plus 15y is equal to 27. Equation 2 into 8 is equal to 24x plus 16y is equal to 32. Now, by subtracting equation 2 from equation 1, we get minus y is equal to minus 5. That is, y is equal to 5. Substitute y is equal to 5 in equation 1, which implies 8x plus 5 into 5 is equal to 9, which implies 8x plus 25 is equal to 9, which implies 8x is equal to 9 minus 25, which implies 8x is equal to minus 16, which implies x is equal to minus 16 by 8, which implies x is equal to minus 2. Therefore, x is equal to minus 2 and y is equal to 5. Now, we can conclude the elimination method as follows. Step 1. Multiply the given equation by some suitable non-zero constant to make the coefficients of one variable, either x or y, numerically equal. Step 2. Add or subtract one equation from the other to obtain an equation in one variable. Step 3. Solve the above equation to get the value of the variable. Step 4. Substitute this value of variable in any one of the given equations to get equations in unknown variable. This can be solved further to get the value of the variable.